Alrighty, everybody. I just got the okay to start our planetarium show, so I'm going to put away our space trivia questions because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. I just want to let you know that I'm here. I'm going to be your presenter. I want to be taking us flying through space today, this afternoon. And I also want to let you know that everything that you see in purple right now is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout our planetarium dome. And I'm very, very excited for y'all to join us for the last planetarium show here because this is by far my favorite to do because this show is called Tour of the Universe. And with Tour of the Universe, it's a 30-minute long show and it's completely live. So you're going to hear my voice for the next 30 minutes. And what it pretty much entails, we're going to be starting off pretty close to the Earth and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully by the end of the show, you won't have an existential crisis of where you are in space. But I do want to let you know ahead of time that we are very small in the grand scheme of things. So just a heads up. And before we get started with our show, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time here in the dome. First off, there's no food or drinks allowed in. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep this theater as clean as possible for all the guests coming in the future. And also, folks, if you happen to have any cell phones, smartwatches, tablets, anything that produces really bright white light or loud sound, now is the perfect time to turn them off, deactivate, and put away for the next 30 minutes because this really takes away from our planetarium show, not only for you, but for the folks sitting behind you as well. And also, folks, if you need to exit early during our show, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where you're going to find the exits before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. If you're a person that has trouble climbing the stairs, don't worry. Once the show's over, we'll have someone escort you to a lower exit in just a little bit. So just stay seated once the show's ended. And also, folks, one last thing before we get started. This show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not flying across the universe, at least not more than the usual. There's going to be plenty of more bad jokes. Just you wait, but it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth, but we're not exactly at the Earth. We can see the city lights down below, right on our globe. But we're going to be starting off at this really cool spacecraft called the International Space Station, or the ISS for short. Now, a lot of people tend to ask me, hey, Christian, what's the International Space Station? I hear about it all the time in the news and articles, but I don't really know what it is. Could you explain it? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. And how this came to be? Well, a bunch of countries across our globe came together to create this spacecraft so they can conduct those science experiments that they couldn't conduct here on planet Earth and near the surface. And they conduct all sorts of science experiments up here at the International Space Station. Some of them being like, how do plants grow in space? So do the plants grow the same when they're way farther away from the Earth with less gravity? Do they grow differently? Another one is something like, what happens when you try to spark matches in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of body mass index. You lose a lot of muscles. Because up here, you don't have a lot of gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And also, folks, right now, the International Space Station looks enormous on our screen, but it's not that big in actuality. It's only about the size of an American football field. So if you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And also, what's really neat is that this thing is going incredibly fast, folks. The International Space Station goes a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this looks really far above our planet Earth, but the International Space Station isn't too far away either. It's only about 225 miles above the surface of Earth. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekends. And just to let you know, folks, this is as far as we put humans into space nowadays, only 225 miles above the surface of our Earth, because it's really expensive to travel out here in space. First, you have to build yourself a rocket ship or buy a rocket ship, and that's quite expensive. And then you have to account for all the rocket fuel, and you're going to need a lot of rocket fuel. And once you get your hands on all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space, so the bill gets quite costly quite rapidly. But folks, this is just our first stop on our tour of the universe, so let's leave the International Space Station behind. We're going to start to see it slowly disappear compared to the Earth down below. So we'll see you later, International Space Station. And before we lose complete view of it, I'm going to add a nice little orbital path so we can keep track of it as we zoom away. Alrighty, folks, we've zoomed so far away now. Now we're looking down at our entire Earth. And I also want to let you know, folks, that the space program that I'm using here is something that you can go home and download and fly through space if you like, just like how I'm doing here in the Morrison Planetarium. The space program that I'm using right now is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll find where you can download it. It's a whole lot of fun, but just a heads up, folks, OpenSpace is in its beta phase, which means it's not completely finished. We may come across a few bugs and glitches here and there. If we do, I'll point them out. Hopefully we can look past them. And also, folks, this program uses a whole lot of processing power and information. So if you have an older computer or something that's been around for a while, you may not want to download it. It may overwhelm that computer. But if you got something new or a gaming computer, give it a try. It's a whole lot of fun. But also, if you're a person like me that doesn't want to download anything, you just want to fly through space, we also have another great alternative called NASA's Eyes. Just like the human eyeball, just type in NASA's Eyes. Don't have to download anything, and you can fly through space just like how I am, and it's a whole lot of fun. So we have OpenSpace and NASA's Eyes. But now that we got a good sense of what we're using here, let's make our way over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science here, and of course, they had some fun as well. They got to play some golf here as well. And luckily, we're inside a planetarium, so I have some special abilities. So let me turn on the daytime on the moon. There we go. That looks much more familiar. But again, folks, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, NASA has a new space mission in the works that's going to be sending humans to the moon in the next few years. This new space mission is called Artemis. And pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we need to figure out exactly how we're going to live out here in space. So the moon is the perfect stepping stone to figure out the logistics, exactly how we humans are going to live out here in space. And what's really neat about Artemis is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has improved greatly in the last 50 years, and our equipment's much more compactable. We're able to do a lot more science in a much smaller capacity. So we're going to be setting up different lunar bases throughout the moon. One great place that we want to check out is the south pole of the moon, which is of great interest. Lots of possibilities of ice at the South Pole, which could be very helpful for setting up a base. Or maybe we want to set up different bases throughout the moon as well. Maybe we want to set up at the highlands towards the north, up here in the moon. Or maybe we want to go take a look at some old collapsed lava tubes, something that we weren't too able to look at too much back in the 1972. But what's also really neat is that with Artemis, they're going to have a space station that's going to be orbiting around the moon at all times, kind of like the International Space Station, just how we saw. So if anything was to go wrong while these astronauts were on the surface, they can launch off the surface of the moon and head to that space station where they would be safe. So again, we humans should be heading to the moon in the next few years, so look out for any news about Artemis. Should be some good stuff. And folks, when we look up at the moon here on planet Earth, sometimes the moon feels incredibly close to us, especially when it's close to the horizon. But the moon is incredibly far away from us. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles, it's kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. We'll see you later. He's so cute. And now, folks, we're going to be heading out into a much larger realm of our solar system because now we're going to see the moon and the Earth as they slowly disappear. In fact, before we lose track of them, I want to add some nice planet trails so we can keep track of all the stuff. And not only that, folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. So there goes the Earth and the moon's orbit. And now the nearest star to us, the sun, comes into view. So here comes the sun. Do. Hee hee hee. And folks, the sun is also incredibly far away from us as well. The sun's roughly about 93 million miles away from the Earth. And again, we're the third rock from the sun. So 1, 2, 3, that's us. 93 million miles between us. Now, that doesn't really put into perspective of how long it would take sunlight to reach us here on Earth. Well, sunlight takes about 8.5 minutes to travel that 93 million miles. So only 8 minutes and a half to get that far. Now, this is a really cool concept to keep in mind because let's say the sun was to turn off all of a sudden, there was no more sunlight being emitted. That last bit of sunlight will travel that 93 million miles, that 8.5 minutes, and then all of a sudden, the daytime would become nighttime here on Earth. And again, this is such a cool concept to keep in mind because this works for really far away objects in space. For example, let's say we're looking at a star that's 70 light years away from us. Well, we're seeing that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when we look at really far away objects out into space, it's like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye perspective of our solar system, let's get a quick refresher of what's here. There's quite a few stuff here. So right in the middle, we have our star, the sun. The closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if I highlight all the asteroids in our asteroid belt. There is quite a lot of them. So there's our asteroid belt. That's where most of the asteroids will be living. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the biggest one. And then past Jupiter, we've got Saturn. And then after Saturn, we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto coming on screen, just down below. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard that before. Well, folks, this is the Kuiper Belt. Woo! That is a lot of stuff. You're probably wondering, what is this? Well, the Kuiper Belt, folks, is the second asteroid belt. Mostly what you're going to find out here are icy asteroids and short period comets that don't stray too far away from the sun. And in 2006, our technology, our telescopes improved greatly, and we're able to see much further objects away from us and much more smaller. So in 2006, we found more than 400 objects out here in the Kuiper Belt region, and we're still finding new objects all the time. So as our technology improves, we're able to find much more further and distant objects, which is the cool thing about science, because then we can rewrite what we know already, and there's a lot more stuff in our solar system. Who knows what we'll find in the next 10 years or so just in our own backyard. But I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And right now, I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So coming on screen right now, we're going to have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction as we swing by. Now, just to let you know, all these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out past the orbit to Pluto, takes sunlight about 5 hours at the speed of light. Only 5 hours. That's not that far either. But folks, let's leave our planetary scale behind, because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Alrighty, folks. So again, right in the middle, that's our solar system. Alpha Centauri is going to be the top left one, nearest to us. And again, 4 years at the speed of light just to reach the next star system to us. But that doesn't really put into perspective of how long it would take us to travel that distance. Well, if you're getting a rocket ship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years just to cross that distance. And that's just a one-way trip. Whew. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then layered the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, y'all, I'm going to be putting up some markers onto our screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 exoplanets confirmed just in the nearby vicinity to us. And that 5,000 number is going to be increasing as the years continue, because we have space telescopes where their whole purpose is to find as many exoplanets as possible. Now, to say if any of them are Earth-like with conditions suitable for life, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed right now, so it'll be a few years before those are developed and then crafted and then launched into space and then operational. So it's going to be a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the far left over here. Let's say that one. And then we find an alien civilization somewhere in the middle. Let's say this one. Well, we'll shoot them a text message. We'll say, hey, we live over here. Take 60 years to get to them. They listen in, answer back another 60 years. That is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers away. And I want to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So let's zoom on out to our Milky Way. Alrighty, folks, we're now looking down our Milky Way galaxy, and can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years to cross the Milky Way from one direction. Woo! And not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be possibly billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I do want to show you what it looks like from a sideways perspective, which is just like so. So we live in a flat spiral disk. When you look up in the night sky, you probably heard someone say, hey, look, you can see the Milky Way. What they're referring to or what they're talking about is this, the galactic plane. So that's what you're seeing up in the night sky. Now, this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That'll come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we continue zooming out, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster in the middle, we can see some towards the bottom, we can see very few galaxies towards the top, and no galaxies directly above us. So you can kind of think of like galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far back now that the picture that we're looking at represents the closest 30,000 galaxies to us across a space of 300 million light years. We've got to give thanks to an amazing astronomy crew that worked at the University of Hawaii who created this amazing representation over decades of time alongside many astronomers. So big shout out to that team. I love flying through this map. But folks, we now have automated systems that are mapping even the most distant galaxies. So now, folks, we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And also, just a heads up, the universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in a flat spiral disk of our Milky Way? Well, if we line up our Milky Way galaxy, it would line up just like this right down the middle. So again, we like to point our telescopes galactically north and south. But astronomers still want to make sure that there was galaxies through the plane of the Milky Way, which we had this nice purple survey right here. You'll notice they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that we haven't mapped out yet. So it's just a matter of time. We just have to wait for that technology to be developed. But folks, it looks like we're running drastically low on time. 30 minutes is just not enough time to talk about the universe, so let's continue pressing on. And now, folks, we're going to be encountering these really distant objects known as the quasars. And these quasars are going to be represented by these nice orange dots at the very large-scale structure of the universe at the edge. And quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, what the quasars are reviewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the very edge of the observable universe, and what we're looking at is something called the cosmic microwave background image, or the CMB image for short. Now, all evidence indicates that the universe we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and those darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. And that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot right over here. And let's make a return trip back to planet Earth, y'all. Alrighty, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of the universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I'll remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders that our universe has. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and peer into the great beyond, allowing you to partake in the wonders of our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And of course, folks, we are making our way downtown, walking fast faces, passing, we're homebound. No. And we're now approaching our solar system, our star system. We're about to pass the orbit of all those spacecrafts we sent down in the 1970s, passing the Kuiper Belt and the orbit of Pluto, and making our way to the third rock from the sun, our home world, planet Earth, the only place we humans have ever called home. All the people we know and love all reside on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back to planet Earth safe and sound. And that's all for now, folks. Thanks for stopping by.